All right, let's look at an example of complex numbers. All right, let's say you have a particle or something, a ladybug crawling on a flat surface, and say it's going to have a movement kind of like this on the xy plane. Then its movement or position can be expressed as this following equation: z of t is in time, and I plus 2t over t minus I. Right? Then let's find its speed at time t. Right? So we can treat z of t just like a regular function, and I just going to be a constant. So we can just take the derivative in a regular way. Right? So you have, right, so let's use the quotient rule. Square the bottom guy, so it's a t minus I squared. Then take the derivative of the top. Derivative of I is 0. Derivative of 2t is 2. Times the bottom guy, so it's a t minus I minus top guy is I plus 2t, and then multiply by derivative of the bottom, which is going to be 1. Right? So if you simplify that, you're going to get, let's see, so we have, right, top one, so let's look at the real part. Real part is going to be a 2t minus 2t actually. So it's actually 2t and the 2t cancel out. Right? Then what you end up getting is a negative 2i minus I. So you have a negative 3i, and then you have t minus I squared. Right? Then, so this is a derivative. So if you want to find a speed, it's just the absolute value of z prime of t. So this is equal to, so we take the absolute value of negative 3i over t minus I squared. Right? So this is going to be, right, we can take the absolute value of the numerator and the absolute value of the denominator separately. Right? Then on top, absolute value of negative 3i would be 3. And on the bottom, we can actually take the absolute value of t minus I first, then square it later. Then you get, so this is going to be, absolute value of t minus I would be square root of t squared plus negative 1 squared would be 1. But we have to square this, and you have 3 on top. Right? So therefore, you will get 3 over t squared plus 1. Right? So this is going to be the speed of the ladybug at time t. Alright? That's it. I hope that this was clear.